Good afternoon. My name is Ravi Babu, Assistant Professor in IARE Institute of Aeronautical Engineering College. Today I am going to discuss about the relation functions of the pulse transfer functions. In that one, I am going to hear cascade and parallel relation. Coming for the first one, cascade connection. In case of the cascade connection, I am taking the one of the function that is having the multiple functions. Here I am taking g of z equal to g1 of z, g2 of z up to gn of z. For example, if you take any function, I am taking as zeros of the function as z plus b and poles of the function as z plus a. For this one, I am going to relation of the pulse transfer function. In case of relation functions, for drawing the relation for pulse transfer function, where the order of the function is we have to analyze first of all. That is, in poles, the highest power is nothing but the order of the function. So, in the denominator value, that is z plus a. For this one, order is 1. That's why, in case of the relation of the functions in block diagrams, that is, it is coming to z power of minus 1. Z power of minus 1. Coming for the first power path, in first power path, we are having the z plus b. So, z inverse into b. That is nothing but z plus b. So, z inverse into 1. It is adding to here 1 z. Next one, forward path is b. So, it is coming to as z plus b. Okay. This is what in case of the numerator part, that is zeros. That is zeros. Coming for the denominator part, that is poles, that is nothing but characteristic equation. Characteristic equation, that is z plus a. Z plus a. Where it is in a function given that it is a positive feedback, that's why, it is a negative feedback, that's why here they given negative feedback. Now it is coming to as positive here. So first of all, one order of this one, the function is z. That one, that's why it is coming to z inverse. Okay, and coming to negative feedback, so it is coming to as a. A is coming to as with negative. So it is coming to as z plus a. This is your cascade relationship of the one of the function, generated function. Coming for the one of the generated one more function is, that is in the function is given as it is an order, second order system. Second order system, where considering the first second order system in this function, it is the pole of the function is and zeros of the functions. That is, the zero will be having the order of square term and pole is also having the order of square term. Coming for the forward path, that is nothing but numerator part. When numerator part is having the power is 2, order is 2. That's why we are having the coming to the realization function diagrams. We are getting a z power of minus 1, 2 times. That's why we get the z power of minus 1, 2 times. Okay. Now, coming for the numerator part, that is zeros function, that is nothing but forward path. So, 1 z and second z. It is coming to z square plus z square plus next 1 z into b1 plus b1 into z, b1 into z. After that one plus b2 plus b2. So z square plus b1 into z plus b2. It is your forward path or zeros of the function. Okay. Coming for negative part, feedback path, that is in case of the characteristic equation or poles of the functions, we having the power also will be 2. Okay. Now coming for first one diameter part, that is constant term A2. Constant term A2. So it is coming to as constant as A2 feedback with negative feedback. That's why it is coming to as positive. Positive. Coming for next 1 z square z power minus 1 will be there. So it is nothing but coming to as feedback as Z into A1. Z into A1. It is also negative feedback. That's why it is coming to as Z plus. After last one is only two terms will be there. Z power minus 1. So Z square. This is one of the form with order to transfer function cascade realization. Cascade realization of the first transfer function. Now go for the one more example. The given function is Z power of in numerator value as Z plus B1, that is one 0 is Z plus B1, that is Z equal to minus B1. Another one is second order quadratic equation, that is nothing but Z square plus BZ plus B3. In coming from denominator value, that is poles of the functions, that is Cascade equation, that is Z plus A1 into Z square plus AZ plus A3. Z square plus AZ plus A3. Coming for here, cascade realization. When we are going to cascade realization functions, we are going to splitting the function into two terms. Okay, that is the given function is as rewriting as like G1 of Z equal to Z plus B1 by Z plus A1 and G2 of Z equal to Z square plus BZ plus B3 by Z square plus A2 plus A2Z plus A3. Now going for cascade relation here. For this first function, already we see the previous section, that is basic function of the order is Z1. That's why we are getting here Z power of is nothing but minus 1 we are getting. Now, in case of the numerator values, Z plus B1. So Z minus 1 is there, it is coming to here with respect to multiplication factor 1, it is coming to as Z. Okay, plus forward path is B1 plus B1. It is what? Forward path, Z plus B1 path. And coming for the numerator value, that is Z plus A1. That is, it is a feedback path with negative feedback. That's why here the summing point we getting here minus value. First one is A1. So it is A1 directly coming. After that one is Z inverse of is adding. So it is Z inverse of adding is negative feedback. No, that is nothing but plus. So Z plus A1. So what happened? This total function is this first total function G1 of Z is going to be cascade with another function, that is G2 of Z. That's why we are going to adding here one summing point, that is with respect to positive. So total this function is going to be cascading to second function. This one, second function. Now draw for this second function the pulse transfer function. So what happened here in the denominator value is our numerator value are nothing but order. First of all, check the order of the system. Order is nothing but what is the highest power of the Z. The order is 2. 2 nothing but in case of the pulse transfer function diagram, we are getting here Z inverse as 2 times completed. After that one, Z square plus B2 into Z. Where is the B2 is there? B2 is there. So B2 into Z, it is coming. Okay. Next, plus B3. This is connection. Straightforward path. B3 plus B3. So Z square plus B2 into Z. Okay. B2 into Z plus B3. Okay. B3. It is your numerator value. Coming for the denominator value. Here, Z square 2 times will be there, and the Z square term is constant term. That's why I am taking constant. After that one, A into Z, A2 into Z. That is nothing but we are having the only one, we required one Z only. That's why here I am taking. In first case, we are taking total. Okay, Z square plus A2 into Z. Okay, B2 into Z. Okay. After that one, constant term. What is the constant term for forward path? That is your B3. This is your B3. Okay, B3. Next, coming for the denominator part, that is nothing but Z square plus 2 Z's will be there. Constant term is A3. So it is constant A3 completed. A2 into Z. So if you want to this one, we are getting here one single word. After that, only Z square. That is nothing but this one, 2Z. Okay, Z square. Okay, this is one of the cascade relation of the function with order of 2. Order of coming for the example, I want to go into making the obtain the cascade relation of the pulse transfer function. Okay, cascade relation of the pulse transfer function. Given for this one is function is z square plus 9z plus 20 by z cube plus 6z square plus 11z plus 6. First of all, in denominator value the power is 3. So the power is 3. So we are having the, in case of the relation function graph diagram, in case of the relation diagram, we are getting as z inverse as 3 times. Z inverse as 3 times. After that one, we have to take the each functions with terms wise. Each function with terms wise. So for denominator value, the roots will be z plus 4 into z plus 5. Okay, multiply this one, z square plus 5z plus 4z plus 20. That is the number, z square plus 9z plus 20 you getting. Okay, it is numerator value. Coming for the denominator value, that is z cube plus z square plus 11z plus 6. For this one, the roots will be z plus 1, z plus 2 plus z plus 3. Z plus 1 plus z plus 2 plus z plus 3. Take the each term as one function. That is z plus 4 by z plus 4 by z plus 1, z plus 5 by z plus 2, 1 by z plus 3. 1 by z plus 3. Now, when we are going to cascade correction, we are in 3 functions, that is g1 of z, g2 of z, g3 of z. For that one, we are going to cascade correction, that is g of z equal to g1, g2, g3, z. Okay. Now, taking these 3 terms in cascade version. Cascade option. So, here the first function is having the power is order of this function is 1. That's why z square, z of minus 4. And it is numerator value is z plus 4. So, z inverse, it is z. It is 4. Z plus 4. Denominator value z minus 1. Okay, it is z minus 1. Negative feedback. Negative feedback. Okay, this is one of the example of the first term. Similarly, go for the second term. Okay, z plus 5 by z plus 2. Z plus 5 by z plus 2. So, it is same also order is minus 1. So, z power minus 1, 5, forward path. Okay, z plus 2, z plus 2, feedback path. Z plus 2. Again, this function also cascade with first function and coming for the second, third function, last function. That is 1 by z minus 1. That is the order is, order of the function is 1. That's why we are getting a z power of minus 1 on term. It is going to be forward path is 1 by feedback path is 1 plus z plus 3. 1 plus z plus 3. After that one, we are doing this one, cascade. Okay, cascade of the functions. Okay, cascade of the first transfer functions. Now, I am going for one more problem. That is 5 into 1 plus 0.25 z inverse, 1 minus 0.5 z inverse into 1 plus 1 z inverse. Okay, for that one, I am going to cascade relation. After this one, for example 1 and example 2, I am going to see the for parallel relation also. Okay, parallel relation also. So, for the first function, first of all, always we have to remember when you drawing the pulse relation functions, the denominator value is and numerator value is with respect to z only, with respect to z functions only. Where in the given problem, it is inverse of z transform, inverse of z transform. So, I am going to one of the mathematical calculations here. That is, first of all, give the taken function. After that one, we have to apply the z power function. Okay, otherwise, they taken directly. See, this is what first function they taken as this one first function. After that one, this one, this one. So, we got a first function, second function, first function and second function. Sorry, second function denominator here. Second function. Okay. So what we have to do? Always the function is in the form of z only, not z inverse. So that's why it is multiplied with z and denominator with z. So what we have to get that is z plus 0.25 by z minus 0.5. Z minus 0.5. Similarly, go for the second part, that is 5 by 1 minus 0.17. 1 minus z inverse. Okay, so what happened? This one is coming to as 5z by 5z by z minus 0.1. Z minus 0.1. Two parts is completed. Okay, so this is completed now. Two functions are, the above total function is converted into two functions. Okay, g1 of z and g2 of z. G2 of z. Okay, so what happened? Take the functions. Once again I am writing g1 of z is z plus 0.5 by 0.5. Z2 of z is 5z by z minus 1. 5z by z minus 1. Z minus 1. Okay, now I am going to cascade relation. Take the first one. Power is 1. That's why z inverse into 0.25. 2 pi series. Okay, z inverse plus 0.25. 22, another summing point. After that one, feedback, that is z minus 0.1. So z inverse 0.51. Okay, 0.5. This is one of the cascade connection. Again, similarly, I am doing like this. Like this, this completed. Okay, this completed. Now, cascade connections is pulse transfer function. Now, I am going to making as parallel part. So, what are the first of all, what the function as I am taking as g of z equal to g1 of z plus g2 of z plus g3 of z up to so on gn of z. Okay, gn of z. If you taking for this one function transfer function y of z by u of z. From this one, output function is u of z equal to output function y of z equal to, taking as y of z equal to z plus z1 of z into u of z plus z2 of z into u of z up to so on. So for this one, I am going to writing the cascade connection. Okay, that is parallel cascade connection. For this one I am writing. Okay, cascade connection. What happened this one? First of all, the functions has z1 of z. Okay, and plus z2 of z into u of z plus z2 of z into u2 of z. U2 of z up to so on like this. I am taking. So here it is a output y of z. Output y of z. For that one, first of all, each function I am taking g of z equal to a by z plus a1. A by z plus a1. Similarly for a2 by z plus a2. Z plus a2. Now, writing the parallel cascade connection for here. Parallel cascade connection. In case of that one, first of all, if you take 3, 1, so what happened? It is coming to as 1 z inverse into feedback path into into a. Okay, into a. This is one of the feedback path. So, in this section, we see the total parallel combinations and problems also. Total parallel combinations are problems also. So, before that one, here I am going to add same as for this one. For this one, I am going to parallel combination. Parallel combination nothing but same function is there, but here we have to go into combining this one. So, u of k is there. And this function is going to be divided into 3 parts. What is the first one? Z inverse 4 and here summing point. Okay, and here summing point, that is what the function is 1. Okay, and it is unity 1 like this. Okay, it is coming to here. So this total function is added to there. One more function is coming to here. This part. Okay, this part. See, again this part is going to be added to here, and again last part is going to be added to here. Total part is going to be added to here. Here. Okay, so this is what cascade connection of the problem. Sorry, parallel connection. Parallel connection. Okay, now coming for this one, in case of the parallel connection, see the problem. We are getting here 5 by 1 minus z, that is 5 by z minus 0.1. 5 by z minus 0.1. Okay, this is what z1 part and this is what z2 part. So what happened? Parallel nothing but just you have to remove this one summing point, make it here and coming to main block. After that one, this part will be parallel combination like this. So input is u of k is there. Okay, from this one like this. Okay. Again after that one, it is adding total functions. This is nothing but parallel combinations. We will see next class some of the problems in parallel combination and series combination also. After that one, we will go for the next topic is Jury stability analysis. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.